Yeah, that's correct.
Okay. I'll have Shane introduce his crew.
We have Nathan over here and Justin. These are going to be the two that are going to be, you know, the users of it and learning it, as well as me and Patrick.
Okay. So let me share my screen and we could start after that.
Did you share with them what you sent?
No, I didn't.
Okay.
I did, but I told them, hey, you were here, just the kind of basics of it.
Okay.
And they know the process from start to finish. So.
All right. I remember when my beard was that dark. A long time now.
I start to have a white one, so.
Yeah. We'll try not to make too many more white hairs for you.
Thank you. Appreciate that. Okay. Let me know when you can see my screen. I have prepared just a little presentation just to give you an agenda, and like that we can follow the different steps we will have during this presentation. So yeah, typically what we are going to see, it's all these different steps. So first we are going to create a vault. So that's been just one part, just like that, with how we create, how we insert new panels, how we insert the connectors with the rules we discussed last time. The material and the edge bands, we'll see that together as well. And after we'll complete everything we have inside. So the drawers and the buckles, and in the drawers, of course, we have many options that we will be able to go through. After that, to create the entire project for a vehicle, we will see the layout feature with sketching from SolidWorks, and how we are going to duplicate our library vaults inside this project to be able to really customize something for your customers, and also have a look of the configurator part to be able to pick the parameters pretty easily and change everything at this time. After that, we'll go through the different data we have embedded in our project and how we can display and create a report for that. And I will show you the results in Excel we're able to do for this part. We'll go through the CAM and the nesting application. And here again, we'll create a report, and this time we would use HTML files just to show you the different options we have. And if we have time at the end, we will discuss and I will show you our SWOOD Center application, which will actually read the information from a model and connect that to an external file, an external database, to be able to automatically update all the projects from an order list you can receive from a sales application or from your ERP system. Okay?
Sound good.
Great. So the first step will be to create the vault, and for that, yeah, we will create and use different features from SWOOD. So we'll use the panel session, the connectors, with the different parametric rules and different type of insertion we want. And also we'll directly view the material and edge band application. Just going to switch inside SolidWorks. So I'm going to create that directly inside my my frame or my library here. So I have one folder I have prepared. So we are going and create from scratch here. So just right click, I create a new one. I'm just going to rename it Vault 2. Edit. And from there, we are going to start pretty easily to have our vault definition, our vault dimensions, and insert new panels inside. So by default, it's that not a regular size. Of course, we can directly come in the edit frame, change the width, maybe for something more standard for you. and after we can just import the panel inside. So for that, SWOOD will help you with a panel feature, and we'll be able just like that to select which part of our cabinet here or vault we want to insert. You bring a truck inside you. So yeah, just by clicking and inserting here, so we got these little handles to be able to connect to the definition of our vault. We can also directly rename here our panel. So that will be, if I remember well, the passenger side. Okay, and when we have the dimensions correctly inserted, so actually we can directly click on a keyboard C to fix our panel inside this. So actually, I just remember that I don't need to start with the with this one. I will start from the top. So here I just click on C, and now we got our panel fixed with the mates inside SolidWorks, but also the dimensions linked to our definition. So let's do the same with the bottom. So we need the back first. So here I can just pull my handles and just connect that to the new faces and fix again everything here. So like we said, let's rename this one. Side. So
we won't have to do this every time. This is just to make the first one.
Anything you can make can be a template for
Yeah.
everything else.
yeah, so here we are really creating something from scratch, but at the end, of course, that's something in the library that we'll be able to customize. Okay. So I got everything. So let's rename this one. And just validate. So when I do that, so actually I'm going to complete my SolidWorks assembly with new panels, new SolidWorks parts. Just, oops. Where is it? And directly all the panels are available here. It's better. Okay, so now we want to complete that. So for that, we are going to, for example, create the connection between our different panels with parametric rules and hardware insertion. So I have created for you different rules. So we have a screw rule for the connection, and we'll see we have also some drilling pattern for the front iron we will insert after that. And the screw dado is already used in the drawer. So I can just now click on this button, and we are going just like that to detect the different connection between the parts. So I can click on that. I can also directly select everything.
Nice.
Mm-hmm.
Yes,
I think you're flip-flopping, aren't you?
Yeah, let's do it like that. And I will be able after to just select my parametric rule to be able to insert everything. Okay. So actually there is some of them that I don't want to have this one. Just the sides, just like that. So for each individual one, after I will have the options to maybe just change the orientation to bring the two first in front. And when I validate, so that's going to create the holes, and we are also able to bring some hardware with that. So without leaving this interface, I'm just going to select the other ones. And here I will just change my rule to select just my drilling information. In here I can manage, for example, the side offset if I want to have a specific one. So what we can see here now is we got additional feature inside our SolidWorks Preview, and we have just like that the drilling done, and at any time we have the possibility to edit any rule to be able to change, for example, the side offset here and update everything just like that. And obviously when we come back and change the dimensions, for example, here, and all the positioning, all the drilling will be updated just like that. Okay, so by default in our panel, we've got 5/8 material. That's something I have said in my template, but we have also the material management, and we have the possibility just like that to create our library. We have some import options, and we got the possibility, for example, to change one panel or all the panels dimensions and material just by dragging, that in our project. So when I do that, I change my material in my SolidWorks part, but I'm going also directly to update the thickness of the panel with a new material definition. And of course, all the drillings will still be correct to be through with the new thickness. So if I do that again, we are going to see now here. Okay, so we change the thickness, but the drilling are directly adaptive with that. Regarding the edge bands, so we have the same thing, and we are able to bring in the edge bands different profiles and different machining that can be processed on the edge bender. And for example, here I can just drag on my edge, and that's going to insert my edge band with my profile and directly create the groove at the same time. So I can drag and drop. I have also directly project management available here, and just like that, I can just click on different parts, and that's going to complete my panel with the edge band information.
Nice.
Mm-hmm.
So once we have done this part, of course, we need to complete with something inside. So for that, we have our SWOOD box features. And what I've done is I've created directly a drawer with the locks and the handles inside, but we'll see some details after that. So when I drag and drop here, so we are going again to duplicate, resize the different panels. We have the options to directly use some counter to rename the part, or I can directly unactivate that, and that will have a standard name. And directly the drawer is going to adapt the dimensions, and we will directly bring different things. So first of all, we will bring all the components. We also bring, for example, the bottom rollers, and we do the machining at the same time. Same thing for the top and the lock. So for example, if I just isolate this panel. Okay, we got the groove, the pocket, sorry, and the drillings directly done. And So what I have done here, it's a possibility on the drawer to directly manage the fact that it's open or closed.
Nice.
And you're doing that with an explosion, or how are you doing that?
So here what I do is I'm managing a specific mate.
Okay, gotcha.
So in my drawer, so I drive everything from my back panel in my drawer, and my back panel have a distance mate. So when I choose, I change the value when I choose to have open or closed. That's it. I could use the flexible options, but the only thing is, as I have SWOOD box for the handles and everything like that, this one are not following directly. I need to open the drawer and everything to do that. When if I manage that with a SWOOD parameter, it's going to do that for me directly.
And we can add as many as we want.
Yeah, after you can totally manage that in another way, and that will be good at the end. Yeah.
Okay.
So what about the handle? So we have on this level other type of SWOOD box, and I got the options here to manage, for example, the code. So we are going to change the type and change also the drilling application, and I also offer for you the side position. So that's the position from the side of the front directly, just like that.
And when we're done being trained, we are going to be able to create these parameter-driven items ourselves, right?
Yep. So same thing for the lock. I change the code, and that's going to change the machining applied, the hardware, and everything. Oh. Sorry, I forgot something. I'm just going to update now. So machining body. Interesting. Okay. So here we'll check that maybe after. So here we got our vault. I just need my bagels at the back. So I can drag the same kind of things at the back. And here again, we can have some options to manage the position from the top and from the side. And the drilling available just like that.
What a feeble lockdown.
So at the end, of course, again, at any time I can change my different dimensions. And all the rules we have inserted are going to be automatically updated with the new dimension of the vault. Okay. So one more thing is sometimes I've seen that you got this special part here for the front. So let me come back to 48. The iron front part. So this one we can of course still use the SolidWorks mates to embed that. I'm just going to where is it? Oh, sorry. Inserts. I think I put that here. Yeah. So for this one, I'm just going to use my SolidWorks mates. So just like that. But what I want to show you is that even with parts that are not inserted, like we have seen with the SWOOD feature, I still have the options to insert my connectors. So for example, I can here again just detect the contact faces between these two, and we'll just insert my drill just like that.
Okay.
And here, actually, I'm going to bring the hardware at the same time. So we got the hardware saved in a specific folder. And they are all here to be counted at the end in the bob.
Nice.
So once we have prepared and done this item in the library, now we are able to directly insert that in a project. So for that, I'm just going to create a standard assembly from SolidWorks. And we are going to create some sketches to give the layouts and the positioning of the different vaults. So for that, I can just start here with, for example, 39 by 48. To give the height, I will just give another here. So that and total. And if I want, I can, for example, create here a new plane, and on this plane, create a second level. So after I have a choice, I can make an offset, or I can directly drag another part. That will be vertical, that will be horizontal and equal. And here, just by giving, for example, 1, 1. So now I got my layouts. So I can save that, for example, in my projects. So let me come back here. So I don't remember the name. It's ECHDAHN 3, 15, and C. Oh. Oh. Yeah.
Who came up with these names anyway?
Where is there? And now I can use my vault here, or I can use any kind of vault I will have created in my library. And I will just right click, insert copy. So every time we do that here, we are duplicating all the panels. All the hardware are not copied. You can see that here. And for example, I can just here rename B1, for example. But you've got this kind of rules here. So we'll create all the new panels, and now we are just going to be able to select the sketch points to position it and size everything.
Will that work for you guys?
I think it's too easy.
So he was simulating, you can create a vehicle opening size. And then just put in, we could have our standard utility mag already predefined in there.
Then you could have, you know, curves indicating, you know, what change in geometry the tire you want. You could do it on all 3 ordinate planes. It's
Well, we're gonna have to get better vehicle outlines then.
Yeah.
yeah, we could just create, you know, 3 ordinate planes with those curves, and mostly have it in the lockdown.
Okay, so same thing for the second one.
That'd be kind of cool for those customs though. You just gotta draw that 2D thing.
Yeah.
And so if you want, for example, on the bottom one, if you want to change for 2 drawers, so actually I will just suppress here my drawer. And I will just add a new panel. And here. Just going to finish with a symmetry here. So when I suppress my drawer, so by default, of course, it will cover everything, but I can edit now my feature here and just say, no, my drawer is coming here. And I can drive my handles position. Just like that. And just drag another drawer in the new empty space. Just manage handles again.
We are going to push our hardware. We're going to push our hardware.
Computers.
Okay. And obviously at the end, if I want, I can at any time change my dimensions. Okay, maybe to create another versions for this. So let's do 15 here. and when I'm going to rebuild. So here again, everything is going to be resized with the new dimension of our sketches.
Ten-second rebuild.
Yes.
Okay.
Stuff.
Huh?
We might have to upgrade some stuff.
So just come back here. So we have seen this, this. So yeah, let's see about the report and the different data. So just to let you know, but so to define the code that is linked to your ERP and the BOM. So we have different ways to do it. So on the hardware that's directly linked to a custom property, on the material that's linked to, so I use a socket reference, but we could use another kind of information. And we will also use the costing type between surfacic. So for LW, I use surfacic. For L, I use linear cost. And for the other parts, standard parts, I use unique cost. We have also additional things and information, for example, the board dimensions that I will use for the surfacic to directly divide the information, the buying length for the linear as well, and same thing for the edge bands. And at the end, we'll be able to generate like that the e-drawing file, the part list, the hardware list, and the stock. I mean the bill of material with all the codes for the material, edge band, and the hardware, and the total quantity directly divided with the rules you had in your the Excel you share with me.
That becomes the BOM.
Mm-hmm.
So just to show you here. So we use the surfacic for the L&W material. We will use the code and we'll use the board dimensions to create the division. And for the other one, we will use here the buying length and the linear costing type. And for the flat, we'll use unitary cost and just the code for that. And for the hedge bands, we got here the code in the reference. And for the hedge band, we typically use the buying length, just like that. And actually, yeah, it's not 12, it's 144 because 12 is feet. And here we use inches.
Do I know?
Is that interface SolidWorks or SWOOD? Have you
SWOOD.
done? Okay.
That's SWOOD, yeah.
Yeah, it's not
Okay.
SolidWorks at all right there.
Can we import that info in? I mean, I think you've already told me we can't tie it to our MRP, but we could probably at least import it.
Oh yeah, we have different options of imports. We can use CSV, XML, and we also have API for you to create your own import feature.
So he was thinking just have it in Excel and we'll just use our normal way we've been doing
To get it out.
it.
I was talking about getting it in.
Oh,
This
okay.
stuff. Yeah.
So let's just save that last time. And I'm just going to check two things before to launch.
Is all that product support information stored in Excel or is it stored in some other format?
Here will be stored in XML and Excel, both.
Yeah, because as we do product changes.
Well, if it's in Excel, we can, via ODBC, get it in. It
Yeah,
can even be dynamic. Hopefully.
that'd be cool.
Okay, so I just click on one button here, and actually we are going to do 3 different actions with this report. First of all, like we have seen, we are going to read all the data and grab all the information from the custom properties, the materials, the HBAN information, and so on. The second part will be, of course, to create the documents. And the last part that we'll see just after we are going to directly rebuild and generate the CAM files. So here we create, for example, the unitary part. It's a part by part programs. In case you need to use it for, I don't know, just one part, or maybe if you have a scratch after the nesting, we will be able to generate that. So after we create all the documents, so we can create images. We are going to create here the e-drawing assembly file as well. And after we'll create the XML with all the data and use a macro to create the Excel file directly, just like that. So that should be about 1 minute to generate something. After I can, during the implementation, we'll be able to reduce this time by removing additional things we don't need. But I wanted to show you the maximum we can here. Yeah, that's done. So we got the e-drawing. So that's a file you can share, and yeah, just with a viewer, you can have this 3D view, measure, hide the parts, or make transparent, just to view everything.
Can you predefine exploded views in this environment?
Here you got one by default. And after, I think it's going to use the one you will create in SolidWorks, if you have one inside SolidWorks. But you need to create one in SolidWorks first.
On floor and build this,
Yeah, the default one isn't helpful. We would have to create a version in SolidWorks.
If you create it while you're building it, it will show up in here. Is that what you're asking?
My first question was, can we define more than one custom explosion? But it sounds like there can be one that you create in SolidWorks, which
Well, you can do multiple.
comes to
You can do it.
and they'll land here too.
Yeah,
Okay.
it could, each different explosion would be a different configuration.
And explosions can even isolate and suppress parts, can they?
Yes.
Can we have a drawer explosion? Outer box.
Yeah.
That'd be cool.
You just do the same thing.
Yeah, give me just 1 second.
Yeah.
Because when you go into an explosion, you can set hide the parts. It's just like a conversion.
A view or configuration.
Yeah, that's all it is.
That word.
I can't remember that one either.
Just one thing. Oh yeah. Yeah, sorry, I will have to generate once again.
So as far as the debug goes, the cool thing is once you draw it,
It's done.
It's done.
Yeah.
It doesn't take
Everybody's going to be converted to debugs at that point because that's going to be the
Yeah.
bottleneck.
Yep.
Cutlass is not going to be the bottleneck. It's only a minute and a half cutlass.
Will you be able to share this model and all its support document with us so we can check it out?
You mean the Excel file you want to have?
The Excel, I take it we can't take this model and have it make any sense in our SolidWorks environment unless we have SWOOD installed, huh?
You will be able to have it, but you will probably lose some information when you rebuild, like the joining from the connectors, for example, and everything.
The e-drawing, you can share the e-drawing.
We could look at the e-drawing, we could also
Yeah.
look at all the HTML results in the Excel.
Yeah. All the reports, we'll be able to share it with you. Yeah, no problem.
Okay. That would be great.
Can this, most of our stuff is like you've drawn out of MDO plywood. Has anyone used this for sheet metal?
It happens. The only thing is with sheet metal, you have the folding and unfolding definition, and sorry about that. I'm just checking because I did changes this morning to generate the. Should check that again. Generate the mix file we discussed, and it seems got trouble now with my Excel. Give me just 1 second.
I did find that we can create a mix file ourselves if there's only individual program files. So that shouldn't be a huge issue.
Yeah, but I found a way to do it. So
okay.
We can do it. It's just when I make changes this morning for that, I maybe mix up something on my Excel definition.
Okay.
Which is too bad.
What kind of things did you find to cover on what you cut out?
What did we do?
What issues did you uncover when you cut the vaults out?
There was it was rounding. One issue was the way this was set up, it was rounding diameters. So ours has to be specific. That was an easy fix though. We just compared the G codes. And then the other thing was depth issue. So when this outputs the G code, we have to add on our spoil board. So we have a special SCM program that does that. And so after that, it worked fine. And then it's just depths. So our machine, you can put the depths in Zilog, and then it combines it with whatever program's made to get the exact depths. And so we'll have to work with that. Because we don't want to change our tool depths, I don't feel, in here all the time. Right. We want to change it on the machine, because they're always changing.
Yeah, and you got two different machines involved, so.
Yeah, it's true. The good thing is they run pretty much the same as far as that end of it goes.
Different tool head layouts. Does that get in the way very often?
I don't think so, because the machine knows, based on what it's doing, knows to go grab that tool.
So this software won't need to know the two different tool head layouts?
I don't know.
That's all in the CNC actual programming software. That's not, your parts should be drawn just as your parts need to be drawn, and then your nesting software deciphers the rest of it.
Interesting that they're nesting here though. And in this prior example, it actually showed the tool head layout, you know, like the L or T shaped portion of the CNC.
Yeah.
You know, doing the tour, which was specific to the way Virginia's set up. It's different than this one.
Yes.
That's the question.
And that's all defined within the machine output parameters. So we just like what we do now, because we go and program it, then we say, okay, well, we want the N100 unloader, which is Virginia's, or we want just the Pradix SN, and that's your post output. So you just choose what post you're using.
Okay, but if we're nesting here, then that is programming, right?
Yes, but so you'd have to have two different post processors, just like we do now.
Okay.
Just one for this machine and one for that machine.
Got it.
Well, yeah.
Okay. Yeah. So sorry about that. It was the changes I did this morning was not. I mean, I mixed something in, so that's why the Excel was not good. So at the end, what we generate here, as an example, is all the parts. So when I mean part, it's the different panels actually. So that's something that has a SWOOD material. So what we got, it's different information. Of course, that's totally customizable. So here we have the material from SWOOD. We have the code from the information we have seen in the SWOOD material library. We can have additional part number with a counter if we want. We can grab the material superior in the same information. Here we have the dimensions. We have the quantity. So, and after we have the quantity for the BOM with the division information we have seen. Same thing here. So here we have one part, but at the end we have this quantity for the BOM when we divide with the dimension of the board, and we can have directly the information about the edge bands here, and it's also available in a picture just like that. Okay, so we have all these lists here. We get also this hardware list with the same kind of information, the quantities directly done just like that. And at the end, we have this type where we got the code and directly the quantity from the BOM available. Same thing for the edge band, same thing for the hardware. And I didn't have the time to go to the end, but I'm pretty sure we should be able to generate the dat file with the good information at the end of the implementation.
Is this Excel sheet a template that you started with as well?
Yeah, so that's a template we use, and we read the XML data to fill this template. And after we decide,
you got a pivot table in there. Will we be able to add additional tabs to this template file and do other things in them?
By default, that will be done by someone from our team because it's management of our configuration file. But in the future, if needed, we can do special training for someone to be able to do it for you in your team. But usually we manage that, yeah.
Okay.
Okay, so yeah, so that's so far what I was able to do. So I don't know if you have any question or any additional needs on this kind of documents.
What would you recommend as a output type for, let's say, the shop floor? A PDF, a link.
I think for the shop floor, we can use this. We generate directly the PDF as well. I didn't show you, but the PDF is already generated here.
Okay, yeah, that works.
So I need to resize the print area, but it's available here. And after we'll have also the other type for the HTML for the nesting. So we can bring the nesting information here. We can bring this information in the HTML. So it's more what you are confident with. I know that people like Excel because they can change inside pretty easily everything. HTML is also great to share with everyone without any other other product software installed on the computer for the machine, for example.
Okay.
So yeah.
Talk to him about the map from the nest, so that we know which parts go with which bolts. The thing we currently get per sheet.
No.
Okay.
So yeah, that was the let's say design parts. So we could move to the CAM and the manufacturing just after. But before that, do you have some questions on the creation, the changes, everything like that?
Just to be clear, once we create this and we like it and we say we want this to be a starting point template, we can do that, and we can do that 1,000 times if we want. Correct?
Yeah.
Okay.
Yes. So now you can, you can create this one directly inside your library and duplicate directly everything, not insert one inside. One more thing I can show you. Yeah, it's we got also the options to directly on this level create some parameters. So if you want to drive here everything, so for example, the different dimensions. So yeah, I'm just going to select here this, and say this is exposed. 8 V1. And for example, the width. Oops. Okay. Here. So now I can have a form here just to change everything. I can create categories as well. So for example, I can create here. I will create just like that. For example, handle. Sorry. And that will be the category hardware.
So basically, we can make it easy for other people to use it.
Mm-hmm.
And that will be linked, for example, we can link that to the different objects. So I can say hardware.
Not very far from a web form.
Right.
Almost just custom programming
Yeah,
to get between the two.
you're right. I mean, it's right there.
It's, yeah.
But we may be able to do it from the
Website.
I mean, the API in SolidWorks alone would let you do it
Mm-hmm.
without SWOOD. As long as SWOOD's API gives me access to this, you could do it.
So here, yeah, can manage that. What else? So
The
yeah,
question, when you've created all of these parameters in this form, can configurations in an Excel configuration sheet drive multiple models based on these, on your inputs here?
I can be linked to a configuration and I can create new configuration with the parameters. So
could I then go into the configuration file and add 20 different lines and have 20 different configuration models just created from them?
I will have to go through each one the first time, but after, yeah.
God, I mean, if you could just
Do all the OneDrives.
It's like, for instance, I have 80 models on the web, of which 50 of them are all 2 drawers of different heights, right? And so if I could make one model and then add 49 configurations driving your parameters, I could have my entire library in 2 hours.
Yeah, after we don't really need configuration because we can create the parameters and drive them directly. So,
But can you do it in mass?
Yeah, I just tried to do it in mass. You know, when you were done, you'd have one SolidWorks assembly with 50 configurations in it that had all the different sizes you needed. And then you could even use a macro to export them all as rendered, you know, models, that sort of thing.
yeah, that could be the next step I will show you with the SWOOD Center.
I mean, it's just, right now, I'm just wondering if it's possible. We certainly don't need to look at it right now. I get hit with that a lot.
Yeah.
Okay, it's fine. It's fine to just, you know, to shelve this one. It's just that's.
Let me think about, because I mean, the fact that creating the configuration through an Excel file in SolidWorks, actually we will need to go through each one to have them available in our list here. So here, for example, I have to create the value. Okay, but I can link my value to configuration. But to have the list of my value, I need to have to go through at least once to be sure I got everything inside. That should do it. We just need to investigate more during the implementation how we can do that. I've started to work on on the automatic update on the handles and the lock. That seems to be pretty good now. When I create a new configuration on my lock level, I will find that in my SWOOD box to be able to change it directly. So on all my previous projects. So yeah, that should be good.
Yeah, it's like.
So yeah, like that here, I can really manage everything and change all the information from one form without going on the different levels. Okay, that's what I wanted to show you with this part.
What part of the tree you just go to that?
Yeah.
Right.
You know, it's like our needs for models is going to be inverse logarithmic.
To not need
If we keep on taking our results and making them parametric, pretty soon we're going to need far fewer.
Yeah.
Starting point.
Okay. Do you have any additional questions on this part?
The only one I have is, and I know we've talked about this a little bit, and you touched on it, is, okay, we made a bunch of models and we realized that our lock hole is off 1/2 inch. Do we just adjust the lock feature and it will update everything as we open them, or do we have to go and drop in that feature?
No. Here, what I have done is to, in my lock definition, I have created a sub-assembly with all the lock inside, and this one is a never copy.
Okay.
So when I change something here, or when I had a new configuration with a new lock, so actually here I will manage my component activation by SolidWorks configuration. I will have the update of my new configuration in my SWOOD box, and all the changes will be done here. But for example, if we change here the position of this one, let's say, I don't know, 2.5. Yeah, let's do something maybe big to see the results. So I change that in my hardware level. So when I come back here, all my drillings, everything is updated. And if I come on this one, and change this here, is going to move with directly as well.
And because all of the locks are in one assembly that's never copied, we can even go add additional locks to that assembly and they'll be available in prior models, right?
Yeah. The only thing I need to finish to check for you on this is to bring the machining correctly. Because I'm able to bring a new component, I'm able to bring the new configuration and have that in my list automatically of choice. The only thing is to have the machining applied. I need to check that.
And this just needs a rebuild, right, for those holes to move?
Yeah. Check. I think it's just.
That's really powerful. There may be other things we want to treat like that.
Yeah, I think almost everything like that, like a Tahoe lockdown will be like that.
Yeah, you had to export from everything again, though, right? You have to
I think if you, well, we'll see on the cam, but let's say we didn't do that. We had 100 that we didn't open, but they need to be changed. I'm hoping once you open it in cam to nest it, that'll be enough to update.
Oh, just like if you open up a drawing, you don't have to open the assembly.
We might be able to do a macro. I know we're not trying to buy PDM Works, but there's something even simpler than PDM Works. We could have a macro open and refresh files all night while we're sleeping.
Yeah. Okay, so that's something that we need to find out though.
Okay, so if we're good, can we move to the cam side?
I'm good. Yep.
Okay, so First of all, on the cam, the thing you need to understand is we are able to save the cam information inside the SolidWorks file. So actually, in my template, when I first create my new panels here with this button and select the right side, left side, and so on. So actually, I already bring the cam information inside. So just to let you know, so that's something we have created from scratch together. But if I open this, okay, I will already find my cam with my joining, pockets, contour, and outside outline definition. When I rebuild, so that's going just to rebuild all the toolpaths, and we'll have everything updated just like that. So what I want to explain here is once we have done that with all the standard operation, at the end, you see I have nothing to do. Everything is going to be done on my part directly. Okay. Obviously, if we have additional, not typical, let's say, information, we can continue to use the standard cam. So for that, I have my tool library here. I can also use my joining head information. And we got here the possibility to have machining strategies that we'll be able to apply by drag and drop. So just to let you know, to show you if I restart from scratch my program, I will be able to drag and drop my drilling, drag and drop my pockets, and drag and drop my contour. And here we will see all the toolpath directly done, just like that. Any kind of part, dimensions, shape, or new things we want to add in our project.
Now, we briefly saw a tool head that looks specific to a machine, but we don't want what we're doing here to be specific to our specific CNCs, right?
I know.
Because we don't want to have to redo this per panel. It's like we're making it in VA Monday and Washington Tuesday. We just want to nest it. We don't want to have to mess with.
I'm assuming there's options that we don't have to define it per machine.
Okay.
So actually, for the drilling head, you don't have, because we don't optimize the drilling, so we don't choose which spindle will go down. We will give the information of the diameter, and the machine will choose the spindle. So whatever the machine you have, if it's the same, if you have a spindle available with the good diameter, the machine will pick up for you.
Okay.
So let's go with the nesting now. So I will just click on nesting here.
What he's saying is each part will have the machining instead of laying out all your parts and then machining it.
Yeah.
Is that good or bad?
I don't know.
Do you have to open each part and do what he just did? Or that's
Initially.
Initially, the first one.
But then it can become a template.
Not really, because as you have seen here, I have done that for one panel that was my template. And every time I have inserted and create the top, the side, the bottom, I already bring the cam information. So here I did one for the first panel only, and that's it.
Oh.
Okay.
Okay. If we check, where is it? If we check the last panel, we have insert here to create the two drawers. Okay. I already have all the cam information inside, so I don't have to do it actually.
Okay.
or like once when you create it. Is that just as the template? Oh.
Yeah.
Yeah. So we create a template of panel with the maximum information. So that can of course be material or can be with edge bands, and of course all the cam inside.
Okay.
So let's come back to the nesting. So in the nesting, first of all, we got here the definition of the sheets. So we have different dimensions, quantity, we can have costing information, the material linked to the SWOOD material library, the positioning of which corner we start, the offset from this corner, the direction of nesting, and so on and so on. After that, we load one assembly, and we can have, for example, 3 like that, and all the parts. And here we are going to detect directly which board are usable for this project. In our nesting, we can manage different parameters. So here I've used a half-inch tool and an additional offset to separate the parts. And I'm going to use cam information from the SCM Xylog cam program on the parts we have seen just before, and position all the cam information in the sheet with the best position and the best optimization. I just click on rebuild. And that's going to create for me all the layouts of my sheets.
So did you do all your material or just one material?
No, that's all the material. We got the half, we got the 3/4, and we got the 5/8.
Okay.
So that one ball.
Yeah.
No, I use 3 quantities for that.
Oh,
I was just saying that. I think that's too much.
Now, currently we label each piece on a sheet that gets printed out with the sales order number or the work order number specific to that unit. Is that capability available here?
Yeah, we just need to have the information in the custom property, and we can display that in the labels here. I will show you just after.
It looks like the nesting isn't quite as good as what we have, but maybe it is. They just
Yeah, might need to play around with some of the parameters.
yeah.
Yeah, you get parameters. I will show you maybe after, but we can also manually change. So if you think that you can find a better optimization, you can manually change that. And at the end, we create always a nesting assembly. So that's an additional SolidWorks assembly. I'm going to save it.
So are we going to have like 10 external hard drives or servers to hold all this?
Because what data?
Storage is cheap. The thing I'm most concerned about is if we have to do it over the cloud,
Yeah.
we need Virginia and which means we'll be replicating.
So here we have all the sheets, and you see all the information for drilling, contour, pocket, everything is available just like that.
Oh, so you can delete or add if you wanted to.
Yeah, I mean, here you can choose to unactivate one drilling operation, for example. You can really manage anything manually at the end. But the fact to create a new SolidWorks assembly, if you make a change in your SolidWorks project, in the Vault project, we always have the link with the nesting, and you don't have to redo everything. You can just come back here and generate the report to rebuild the programs at the end.
Okay.
So I'm just going to save at the SWOOD nesting, and do I have that here? Okay. And now when I generate the report, so actually now we are going to create again all the programs, but also all the documents for the nesting. And so just by activating this little checkbox, we activate a custom property, and we will generate other documents. So we will not generate the Excel again. We generate HTML files. We don't generate the drawing. We'll generate only the HTML file for the nesting process.
To cut parts individually or do a bridge type nesting where basically when you do the cutout, you don't stop that bit until everything's cut out. You connect them all.
Not sure to understand.
So when we run parts, you can cut out one piece at a time and then the bit, or you can have all cuts connected. That way parts don't move until the very end, basically.
So that's part of the strategy we can insert. So we have the options to insert not only one contour, but two contours to create like a onion skin strategy. We can add tabs between the parts as well. That's in the manual nesting. You can add bridges between the panels to keep the vacuum and some material between the small part, for example. So yeah, we get these options. Yeah.
Okay. The main one, because we've tried tabs and onion skin and all that. The biggest benefit to us with our current nesting software is you can drop in a bit on a long cut, and that bit won't come out until every piece is cut. So you'll basically go around half a part, then go to the next part, cut out half of it, and it just continues on a continuous path. We call it bridge nesting, but I don't know what other term is out there.
Yeah, we will not have this option because today, no, we don't have this kind of options for nesting. So we will do part by part, and we'll have the tool will go up and dive again on the next part.
Okay. So far, that's a huge downside. Only for speed issues. So
Okay.
just something we need to consider.
Can this thing gather everything into DWGs of different thickness materials and then pull them into our regular nesting environment?
I don't know.
Did you hear that one?
Yeah, I did. No, we will not be able to create DWG from there. The DWG we are able to create them for from a SolidWorks drawing, for example, but not directly from the program.
This optimized cutting, is that something you guys would be able to program?
I need to ask. I know we got some enhancement for nesting coming for the next version. I need to ask if this kind of cutting toolpath is part of that or not.
What I can do is I can record a what is it called, like a simulation run in AlphaCam, showing you exactly what I'm talking about.
Okay. Yeah, that could be interesting for us to check that. So here we got the list of the jobs, so each sheet, and after we can go inside, we have some details for each sheet. And finally, here we'll have the labels for each individual sheet with all the information we have seen. So we have the edge bend, the dimensions. So the order, that will be something from the custom property we can have as well. But we can, of course, customize the labels as well. And of course, so here I have created this this mix file, but we have here the nesting programs and the P2P programs generated just like that. And the mix file you can directly open in Xylog. Just find it. Yep, here we are.
Okay.
Okay. So yeah, so that was the last part of the presentation. So after the report. So we got the CAM to generate the PGM and the mix file, and the document specifically for the nesting.
So just to recap what Patrick was saying is we do have the, let's say we call, you know, that stock code that you saved this assembly as, we could have it spit out on the parts, that stock code on every part that would go to that assembly on the report.
The report is always generated from an assembly, so you will always have the report from this assembly, yeah.
Okay, and then either way, it doesn't really matter, I don't think.
Looking at 3 units with the same stock code, you're gonna have issues getting 1 unit.
They usually combine them anyways on carts.
Do they?
Yeah.
Okay.
Then
The same vault, yeah.
the other thing is, can you show us an example where you're nesting 2 completely different units? So not, or just tell us it's possible. So not quantity 3 of that stacked vault, but that stacked vault in addition to a single vault, and how that process would be. Where would we select the different ones?
Yep. So I will restart from there. I will just create a nesting with this one. So here I will keep quantity 1. And here on my source file, I can right click and just select another one. So for example, the one we have in the library.
And we could just load up as many as we needed to.
Yep, you have the quantity for each individual one, so you can manage that individually. Yeah.
Okay.
How do you know which part is what?
The stock
code.
We'll save everything as a stock code.
No, I mean like inside the nest.
It tells you, I think, what part is what stuff.
Yeah, we can have it on each one.
Yeah.
Yeah, here you have you can see the name, but we can bring other information from here. So we can, before to run the nesting, for example, we can run a macro to write in each individual part, to write the name of the project, of the code, the stock code, and after we can display it here in the different information, in the labels and everything like that.
Okay.
But that will just need to have an additional actions to use this macro and populate the assembly information directly to all the parts, to have, for example, the customers, all this kind of information to have be available in the nesting and in the different labels information. Yeah.
Okay. And then one other thing is sometimes we have parts on a model that are too small to run on the CNC. Is there a way to quickly check to allow or disallow nesting?
So here you got all the parts and you have the different dimensions. And after on each one here, you can just right click and disable a part if you want.
Okay.
And that's linked to a custom property. So yeah, I think in a condition I could check the dimensions and this custom property to directly and automatically disable it. Or you can just come here and just right click disable.
That'll work.
Of course, you need to rebuild again. But we'll update the nesting results.
Well, remember it's more than, you're seeing 1/2 inch, 5/8, and then 3/4.
Oh, gosh.
Yeah, normally it would be. It's like, what?
Wait a minute, that's.
No, see, the first sheets are
Yeah.
1/2 inch, second sheet's 5/8, and then the last one is I believe that's what it looks like.
Even the comp doesn't, it's kind of strange optimization. You'd think you'd have the first drawer fronts, you know, all set vertically, and then the other pieces.
So yeah, just to let you know, but like I said, we can manually change everything here if we want. So I can try, for example, here to enter one part to another.
There you go.
Yeah, okay.
I thought you had to go with assembly. So that's nice.
I can also change the order of cutting here. So it's 1, 2, 3, 4, 5, but I can do 1, 2, 3, 4, 5. And here I can also add my my bridge between parts. And that will be something we see at the end, of course, on the toolpath.
Okay.
Now, is it doing all the work with one tool before it goes to the next? At least, I mean, drilling all the 1/8 holes before it
Yep.
goes to doing outlines. This one.
Yeah, we optimize when we combine the part programs in the nesting, we optimize by tool. Yeah.
Interesting is how we have it is it will drill a hole, and if another diameter hole is right next to it, it will stop, do that one really quick, and then continue on. Same happened in their program. So it optimizes, I think, based on what it is. It's like the drilling head. You don't want it to do all the holes and then come back around and do it again when they're right by each other.
Right.
So yeah, it seemed to be doing it correctly, how we like it.
So here we got the new sheet updated with the new position. And all the toolpaths are updated on the new position that we have prepared manually.
On that bottom with the 2 drawer, he's got 3 sets of rollerball holes for each drawer instead of just 2.
Yeah, I'm sure that's something we can dial in.
Yeah, that was how the design was.
For a 2 drawer, it's only 2 on either. It's 1 on either side.
But I didn't give him the rules.
Oh,
Yeah.
gotcha. Okay. I was like, wait a minute, there's a lot of holes. Yeah, if it was a 1 drawer, then it would be a center strip.
And I think that's the beauty is we can
Yeah.
dial all that in wherever
Okay.
we want.
If we want to change it one day, just
Yep.
update it. Fresh day on the weekend.
Okay. Anything else?
I don't have anything that I can think of. That's a lot to soak up.
Yeah, it is quite a bit. We still want to see your machine specs, see what you're driving. Unless he sent them to you, did he?
No, I don't have.
I haven't seen them.
Sorry, I don't get it. What?
Oh, see your computer machine specs. Just so that we could kind of extrapolate how long it's going to take for our hardware to do some of the things you've been showing us.
So you want? Sorry, I don't.
Yeah, just your graphics card processor.
Oh yeah, okay.
Amount of memory, that sort of thing.
You just have to pull it up right now. It'll be.
Yeah, you can pull up the info screen on your computer. It's being recorded.
I don't know where to find that system information.
How does he find it?
I think he's there. He's only got 16 gigs of memory.
Graphics.
You see it?
Display, or that's actually your monitor, isn't it?
Yeah.
P1000.
P1000.
We have a P4000.
I have a 4000. And I have 32 gigs of RAM.
That's not very much.
Huh?
It's not very much what it's using.
No.
No. Are you all SSD or do you have some spinning drives left?
Yeah, I got the SSD drive.
Okay. Yeah,
I have an
I'm
M.2.
packing a whole bunch.
I have an M.2 SSD.
This thing outstrips everything. Okay, thank you. Are there any utilities that let us update libraries of models en masse? For instance, if we did decide to do a lock change, can we do update the lock assembly and then tell the system to update all the assemblies that use that subassembly? You know, basically open them up, refresh the models, or is that all more PDM work sort of stuff?
I think you can do that with the macro pretty easily. So we could check to do that maybe for you at this time, but you really don't need it actually. The way the way we have seen, the next time you open the file, it's already updated.
Okay. Here's the use case. We have 7,000 D-book drawings that our salespeople use to send out to customers. And so if we made a lock change, it would be nice to open up every assembly, update the lock, and then have it print out a new PDF D-book support drawing that automatically ends up in our information given to the salespeople. And so it's more that sort of thing that inspires the question.
So let me see this last part actually. So like that, I think it's something we can discuss. So on the SWOOD Center part, so we have seen we can create the configurator with all the different parameters. What we can do as well is to declare some product as articles. So we are directly linked to a SolidWorks assembly, and we can just run our SolidWorks in the background, okay, to define to after define new components from this article, new project from this article. So here I'm going to open a client interface, and I'm able to read an XML file, for example, with a list of different order and lines. Okay, and for each one I can have different information of the dimensions, the log codes, the position, and so on. Okay.
Yes.
And so that can be linked to here, for example, the XML file, but we can also be linked to a SQL database. We can be linked to an Excel file. And if I refresh here, so I'm just going to launch a run. Oh, yeah, sorry. Because I changed the name this morning.
Center manager.
Here. So yeah, let me create first another one.
Can this same utility be watching a directory for files to show up, and if it does, it'll process them?
Yeah, the thing here is this one is one I use for demo. So actually, I'm not reading this information from a database. I'm reading them for the models we have inside SolidWorks. That's why I have the access to all my value here, and I can change that. I'm just going to change to be in inches here. Yeah, that's it. And so here I'm going to change this one, and that. So yeah, when that, it's pretty quick. Because I need to check this.
you change the vault size inside here?
Yeah, that's what I get.
Can
And
the
locks
salespeople
and
have
carpet
that?
and
Can have that thing and then it'll print out a new PDF?
So what we are going to do here is to open our article, read the information we have here, populate it inside, generate the report, and close it.
exactly what you were wanting.
Mm-hmm.
Okay.
As long as you do 47 lines with different info.
So for me, I mean, that can fit with what you want to open all your library and update with the new options you have inside. Okay. But that can also be linked to your sales application to automatically create all the jobs for 1 week, for example, directly from the sales database. Okay, so I see that in both things for you. It's you got your sales guys that create the orders. I don't know which kind of interface you have, but at the end you have a list of order lines. For this customer, I need 2 volts with these dimensions and so on. For this one, I need another one, and so on. So we have all this list available here. Okay, we have all the parameters, and when we just click on one button, and we are going to actually recreate all the different projects just like that.
Okay, a batch
So-
day.
Mm-hmm.
All the SolidWorks file will be automatically updated and created. So if we check here, okay, we see we got the new ones that are created just now. Okay, the 1.1 and the 1.2. And at the end, I will show you, I can also create a nesting job for that to create directly the nesting with all the lines combined together.
But we won't be taking, you know, an existing stock code and changing its dimensions.
No, but we
Based on
don't
that.
have to use that feature. We could just use the lock, carpet, handles. We could
Oh,
use
gotcha.
those features.
Mm-hmm.
Okay, yeah, make the job though.
So yeah, here once we have the definition of our vault in the library with all the parameters we know we can manage manually, like change the handles, change the lock, the dimensions, any additional things that we know we can drive. So actually we can grab the information from outside and automatically rebuild all the jobs for the week from one cell guy. From I don't know, after it's pretty flexible. Just how we will manage this client application to be able to do it. And we can also read some. So in our rules, we can write, for example, some message error. So maybe the dimension is too small. This option of lock is not available. All these kind of rules, and that will be also displayed here as a message to show to the guy using it. But we can also populate that back in the sales application database. Like that, the guy can see, okay, I've done a mistake on my order. I need to change my code reference for the log, for example. Okay. So here we have created all these files just like that. So we got all the different Excel file, everything is available. And after we are also able to directly create job nest. Select a nesting configuration, just like that. And I just need one more thing. No, I don't have it. So just to change my nesting. And here, just create the nesting file for the job. Or we can create all of them at once, but we can do that in 2 steps also.
Okay.
So yeah, that's the last part we discuss quickly together. So if I show you here, yeah, that's what we name SWOOD Center. It's another module, so we can read the data from any kind of file. We use a client application to collect the order information and parameters and send some queries to our models to rebuild the CAD, the CAM, check the message, send answer back to the client application and to the data file. And if it's okay, just generate the report, the documents, the programs, and so on.
Sounds good.
Okay. Yeah, so I think that's pretty much everything I wanted to show you today.
One thing we didn't touch on is drawings. If we were to create in a one drawer template a drawing with views that we are used to on the shop floor to build it and save that as a template, we could then resize it and it'll resize all the drawings as well. Correct?
Yeah, the drawing is actually, so I got my SolidWorks running, so that's able to show you now. But the drawing, if you create the drawing with the frame you have in your library, every time you insert your frame in a multi-level project, or every time you copy to create a specific project, we'll be able at the same time to duplicate the drawing. And of course, all the changes you will do in the assembly will be populated in the drawing like any SolidWorks file.
Okay. And then when we want to finish, like you were creating all the documents, we could select to go and grab all those SolidWorks drawings as well.
Yeah, from the drawings, we are able to generate PDF files directly.
Okay. That's good. That's all I had.
Okay, me too.
I think that's all I have too. If you can share the packet of information on this, 3-drawer build, specifically the PDFs and HTML files, that would be cool.
We want to share it with our production team and make sure they can read. I mean, I know we can change this, but we want to make sure they are okay with these reports, basically.
Yeah.
Right.
Yeah, sure. Yeah, I will create a zip file with all the reports output, and I will share that with you. Yeah.
Okay.
No problem.
All right, and then you and I and Patricia will be speaking tomorrow.
Yep.
And then Shan and I will start calling references as well. We haven't done that unless you have already.
No, I do want to do that.
All right, so keep plugging away at this, but this is still looking great.
Yeah.
Good.
Optimizing the CNC cut is intriguing. But
Yeah, I will definitely send you something on that, just so you can see what I'm talking about.
Okay. Yeah, and I will check from my side with the programming team if it's something we can integrate in the near future.
Yeah, one thing we did discuss for the training, is that gonna, with COVID, is that gonna be remote? Because we've done other training where we fly out places, but I'm guessing it's gonna be a remote type deal.
Yeah, that will be remote. We have planned some on-site days after training and implementation, but for now I'm not sure if we will be able to travel again this year. So so yeah, let's see. I think yeah, that's something we will also discuss tomorrow with Patrick, but I think we will start with training and implementation on remote sessions, and if we get a chance to travel in September or October, we will also come to visit you to spend some days together and go deeper in the details you want to see with us.
Okay. Okay, well, thank you very much. I know it's getting kind of late for you at this point, so.
Yeah, no problem. So yeah, I'm going to share with you these files from the report, and yeah, we have this meeting tomorrow, and we stay in touch. If you have any other questions, don't hesitate to come back to me.
Okay, hey, thanks for the work on this. I know you put a lot of work into this.
That's okay. I mean, you paid for it, so
Okay.
so that's normal. But you have a job that you like at the end.
Came together quickly. Impressive.
Thank you.
All right. Thank you.
All right, bye, Bruno.
Oh, if you can send us a link to the recording, that would be
Yeah.
great.
I think that will be available just after. So yeah, let's see. I will close. We will close that, and I will share with you the link after that.
Okay.
Okay.
Thank you much.
Thank you. Have a good day. Bye.
Bye.